afternoon. For some reason, I don't see the chat. I'm not sure why I don't see the chat. So I did just post a few questions in Moodle. I forgot last night, or I didn't get to do it last night. But I posted them now, and as people come in, I'm going to give you some time to try them. Okay, so let's, you can find them in the Moodle page, or I'll put them up here and give you some time to work out the problem before I answer it. Alright, so you can look into your notes or prepare something. Okay, I'll give you 5 minutes to attempt it, and then we'll work on it together. Hello. Okay, so these are found on the Moodle page as homework. Hello, Delia, Isadora. So just, I'll give you 5 minutes to try, and I'll check back. Okay, so give it a shot. Okay, I hope you hear me fine with no feedback. Someone complained about that. Delia complained about that. I hope that's better now. Let me know. Okay, the answer, Natalia guessed B. The answer is not B, but thank you for giving it a try. So this is an example of a paired t-test. What you have are outcomes on the same person. So a person is their own match, sober, and then after having some wine, 3 glasses of wine in fact. So all 5 participants in this study had 3 glasses of wine. Before that, they were asked to perform a task, and then after they were asked to perform the same, or it's a small puzzle, okay, was while sober, and then again after drinking. So it was, the task was to solve a puzzle. And how do I analyze 2 sets of data? Well, I taught you if you have a matched pairs design, you don't need to use the original values. You collapse them into a new data set and work with the difference values. Okay, so then you don't analyze these anymore, you analyze the difference. And when you do that, you don't analyze these either, these are going to throw you off if you look at that. So what you're going to do is take this data, these results, and conduct a test on those results. Notice you have only sample information. This is all sample information regarding the mean. So this is a test for means. And in particular, you're testing to see if there's evidence that the true mean time to complete a puzzle is longer after. So it's going to take them longer, presumably because they're intoxicated. It's going to take them longer. And so it's showing that alcohol can impede your thinking. At least 3 glasses of wine can. So the results are, then this is the tricky part, you have to subtract these things properly, okay? Not tricky, but you have to be careful. This is a point of caution. You need to subtract the sober, well, depends on you subtract. In this case, they subtracted after the wine, which should be a larger number, minus sober, which would be a smaller number if that's true, right? If it's true that it takes you no difference in time, or sorry, it takes you longer with the wine. But okay, so what they did though is they subtract the sober by the after. So what you would expect is, well, what you're looking for is you're going to compare whether there's a change, and the kind of change you're looking for is that sober is a smaller number than after. So this would end up being a negative. So here that's the case, right? Takes them longer. Here it doesn't, but here it does, here it does, here it does. So it's probably going to be true just looking at the numbers, but it's going to depend on how variable this variable is. We actually want to take the differences and standardize and see how many standard deviations we are away from the hypothesized mean. What is the hypothesized mean? In fact, the hypothesized mean is so let me write this up. So A I have trouble making the dots. So you're going to do this for a mean difference, and the difference, if there's no difference, right, status quo, no difference, no effect of drinking alcohol, in other words, that would be 0. And if there is an effect that increases the time that it takes to complete the puzzle, the way that we subtracted means that this would be a negative. Okay, so that's what you have to look at. If you set this up yourself, you might not have subtracted them in that order, but in this problem, that's how they're subtracted. So that's why the answer is A. So I didn't put the little d down here as a subscript. It's not critical. What's critical is that you use the difference data. Okay, so the answer is actually A. Alright, so let's go through the other ones so you know why those are not the answer. Okay, first step, remember, all hypothesis tests always have the form, the parameters here, whatever number I put in the status quo statement, I put below. So notice this cannot be the answer, and this cannot be the answer because it's working with the sample mean as the variable of interest. It's not the parameter. Sample mean is not the parameter of interest. We're interested in the population mean. Okay, so those are all wrong. And then this is wrong, right? Because this is just saying, well, actually, that they're the same. That they're the same value versus that the sober is greater than the wine. Actually, this is wrong, right? We're going to see if the wine is bigger than the sober. So this is not the way we would write it, but this part is kind of okay because this is just saying that they're the same. Saying that they're the same is the same as saying the difference is 0, right? Because saying they're the same, I could write US minus UAW equals 0, which is actually the U difference. So those are all the same statement as this one that says they're the same. But the problem is that this is the problem. Because I'm not going to be looking for the sober time to be larger on average than the drunken time. I want to see if the drunken time is longer, right? So B is not correct. So these are tricky, right? If some of you guys guess B and D, so the D is also tricky. It's just doing it the wrong way. It's the wrong way. So that's why the answer is A. So if you have to go back through that, if you didn't follow what I said, convince yourself the answer rests in here, the way they difference the numbers, okay? They set it so that you're going to take the sober values, which should be a smaller time to complete the puzzle, if we reject the null, minus the drunken time, after drinking the wine, and then this would end up being, because you take a smaller number minus a larger number, these would end up being negative, and it looks like they kind of are. So we haven't solved the problem, we just set up the hypothesis, but that's the approach, all right? So if I was giving part marks, I wouldn't give any points to E, and I wouldn't give any points to C, okay? Because that's way off. Always use the parameter, not the sample, as your variable that you're conducting inference on, or not your variable, sorry, your parameter that you're conducting inference on. So then the other ones, I have a little more mercy for something like this, B and D, but they are wrong. I would maybe maximum give you half the points for that. So often I will, if this was in the long answer section, I would take off, I usually leave 2.5 points for the hypothesis testing. So I'd probably give 1.5 if you chose the wrong one. All right, so let's do the second part. The second part of the problem involves computing the p-value. So you're going to conduct a few parts of the test. Should I give you some time for that? Let me give you 5 minutes for that. So I'll just move it up. So now we have the hypothesis. Compute the p-value, and I'll give you 5 minutes to try that. Okay, Jan, you got the right answer. It is B. So let's do this together. What we have to do is calculate the p-value for this test. It means that first we get the test statistic, right? We're going to calculate, in this case, the t statistic because this is from an experiment and we don't have any prior information. We don't have any information of the population, standard deviation, or the mean, of course. So what we're going to do is calculate a t statistic, which is computed as, let me get rid of this. So the t-stat will be the evidence, which is the mean of negative 29.4, minus the hypothesized value, right, the mean divided by the standard deviation over root n. This is from Formula 6 of the formula sheet for mean inference. So we're going to calculate this is equal to 20 minus 29.4 minus the mean of 0. Don't forget, this is for, a change. This is for our experiment. So the status quo is no effect, no change, 0. And then S is 23.5. And that's a 0.5. And then divided by square root of 5. When you put all that together, what do you get? It's negative 2.80. Okay, so negative 2.80. Now, do I know that represents an outlier? Is that far away? Seems kind of far. But to really know, I need to check. Let me erase this. I need to check that if I consider the t distribution with negative 2.80, I want to know what's the chance of being out there. I want the tail probability of that result. What's the chance of being here? Okay, on the T4 distribution. So I will go to the table. And look for that number. Actually, okay, let me say the table does have 3 decimal places. So let's do 2.797. I hope that's not confusing. I wish I could erase this. Can I erase this? Oh, I can. No, I can't erase. Anyway, I'll leave it like that. It's close enough. I'm just thinking if the actual value 0.797 is there, it'll make it even easier, but it's probably not. So let's look at the table. And tell me, on the table, you remember that you're only going to get the right side. So on the table, the thing that you're going to see is, and I'll write it up here, in the table you're going to only see the right side, right? You're only going to see this way. But nonetheless, check on the right side for 2.80 and see what you get, and then because of the symmetry we can say it's the same on the other side. So what's the probability of this? Now, if you use Excel, you get the precise value. If you use the tables, you're going to get between 2 and 2.5%. That's how you find the answer. Okay, so when you look this up on the table, this is going to be between 2.5, sorry, 2% and 2.5%. All right. So if you are confused, let me see if I can find that in the tables for you. Where can I find the tables? Guess here. So I'm going to go to the tables. So remember the tables, what you have to do is go to the fourth row and look on the fourth row for 2.8. 2.8 will be between, see this is very close. It was 797, so 2.8 will be on the fourth row will be between these two. So it's going to be between 0.2 and 2.5. What did I say? 2 and 2.5. Or 0.02 and 0.025. Right? So 2 and 2.5%. So that's how I get that. So going back to the problem, that's how we get answer B. Alright? So you just say between these two because we don't have the precise value. If you use Excel, you can get the precise value. How do you use Excel? I put the code in on the Moodle page of how you get that. So you can verify that. Or you can just go on YouTube, or you can use a calculator online. There's many ways to do it. Just make sure you know what you're getting, given what you punch in. Alright, so I'm going to go to the next problem, unless you have any questions. So here's the next problem. Here's the two parts. I'll give you 5 minutes. Do as much as you can do. I'll make it smaller, maybe. You can see the whole thing. There you go, 5 minutes. Okay, I'm back. Let's see if we can set this up. Carbon monoxide is a colorless and odorless gas. Even at low levels of exposure, carbon monoxide can cause serious health problems. A home is considered safe if the mean, so this is a problem of means, CO concentration, right? Monoxide is only one oxygen molecule, I guess, is 4.8 parts per million or lower. That's the key word. We take a random sample of 8 readings in various locations of a home. These readings have a mean of 5. So here's the sample information. 5 parts per million and a standard deviation of 0.5 parts per million. Assume CO2 readings follow a normal distribution. We would like to conduct a hypothesis test at the 1% level. Okay, so this is all the underlying stuff is the important stuff. Alright, so let's set this up first. We have to conduct most of the steps here, basically, because all I want you to do is find the p-value and then assess the p-value in the second question. For the first part, we need, I want to set up the hypothesis test. So I'm going to conduct the 5 steps regardless whether they're asking me or not, because I need it for guidance. So some people have written the p-value out. Go ahead and write your p-value. So it's going to be H0 versus HA, and it's a test for means, and this always has to be an equal sign. So now this is going to be useful because they say we want to test that it's safe, that's the status quo, against that it's not safe. Status quo is no effect, right? Nothing serious, nothing major, something new, nothing to report. So it should be 4.8 or lower. So the number 4.8 is going to go here. You're probably okay with that. And I already told you, whatever you put there, you need to put in the alternative as well. And then in the alternative statement, if H naught, the null hypothesis is supposed to report no difference and no effect, so it's safe, in other words. The alternative should show that it's unsafe. So what we're going to put in the alternative is greater than, because if it's greater than, then we have found something to report on. Okay, so that's the test we're going to conduct now. We're going to calculate a t-statistic because we have no population information here. All the information given, and there's no population standard deviation. It's all from the sample. Okay, these readings. Notice, I'm telling you how to read this because it's very important to be able to identify the sample data and distinguish it from the population data. So it says the sample of 8 readings and the results of the 8 readings. So this is all sample information. So this is S and this is X bar. So let me write that down. So X bar is 5 units and S is 0.5 units. Alright? So then when I calculate the t-stat is the mean that I got, my evidence. Okay, now it's starting to get shaky or blurry what you're supposed to do. You take your evidence, the evidence from the sample is 5, and I have to assess it by taking the mean and dividing by the standard deviation from the theory. That means that the best I can do is calculate with 5 minus the hypothesized mean, so this is always the hypothesized mean, so it's minus 4.8, very close, divided by the standard deviation, which is 0.5 over the standard error, right? Over, in this case, n is for formula, this is formula 6. So all these problems are with formula 6 I've been doing so far. And you get 5 minus 4.8, and you divide by 0.5, and then divided by square root of, and I get, what do you get for p-value? What do you get for the t-stat, I mean? The t-stat is negative 0.2 divided by 0.5 times 2, essentially. So it's negative 0.8. Now the question is that significantly different from, sorry, is that too far away? It looks not too far, right? It looks like we're probably going to fail to reject and everything's going to be safe. But let's just double check with calculating the p-value, because we're not so familiar again, remember, with these kinds of distributions. We don't know if that's an outlier, probably not, but so the degrees of freedom, when you have 8, we have 8, observations, so degrees of freedom is 7, so we're going to use T7 to do this. So on T7, I want to check if it's I want to check if it's greater. So this, to get the p-value, I need the alternative hypothesis, greater than sign. I'm going to check to see if it's greater than what I got. What I got was negative 0.8. So I'm going to plot that. I plot my t-stat. Oh, I did the wrong side, right? Because it's supposed to be negative 0.8. So I'm going to plot it on the correct side. But remembering that the table only gives me the right side, so I actually end up having to go onto the table and look at the 0.8 and where does it fall. So let's save this. So I go onto the table and I look on the 7th row and I see, where does it look like there's 0.8. So it's between these two somewhere. It's very, it's not in the rejection region, right? It's very close. It's not far away. So it's between 20 and 25%. So between going back where I left off, did I get the right answer? Did I get the wrong? Oh, you know why? Because I used 4 here. I thought I did something wrong. Sorry about that. This is not a 4. This is a 7. Let's do that again. It's okay. Because I was heading down the wrong path. Okay, so this was an 8. I don't know. I have I do this all the time. I have the previous problem in my head, so there's a warning for you guys not to do that. So let's calculate the t-stat again. I'm going to erase what I did. Sorry. You get to see real time problem solving. Okay, so let's do this properly. See if I can erase this one. Yes, okay, back. Do this again. Sorry for confusion. I used the wrong number. So this is going to be equals 5 minus the mean was 4.8. That doesn't look like 4.8. Divided by S, which was 0.5. 0.5 divided by square root of 8. And I apologize again. So it's 0.2 negative on the top divided by 0.5 times 8 square root. Negative 1.313. Right, Sonora? So let me do it one more time. 0.82 divided by 0.5 times 1.31. I get 1.31 with a negative. It's a negative. Be careful about that. Very good. Okay, so now same sort of drawing. So I'm going to draw this like this with negative 1.31. Make it higher. Or 131. Okay, negative 1.131. And going this way, we look it up on the table. So let's go to the table. Thank you, Isadora. I blew it on that one. So let's get the table, the bottom of the notes, the back of the notes, and we go to the 7th row, and we look for .131 will be between. On the 7th row, it will be between these two, which means it's between those two. So between 10 and 15%. And that is what I get. Okay, so between 10 and 15%. So the answer is to say between 10% and 15%, which is D. Okay, so I messed up by using the wrong sample size. It was the sample size from the previous question, I think. or with the degrees of freedom from the previous question. Okay, and so what did we conclude? This is not far away, right? It's not in the reject region. Reject region would be with 5%, so that's going to be here, closer in, so you're actually going to fail to reject. You didn't find anything strange. It's within reason to have seen 4.8 as your average, when the average is actually 5 for the population. And so, without looking at the options, we'd say something like, there is insufficient evidence that the home is unsafe, or there's sufficient evidence that the home is safe, something like that. And so I think that's option C. There is insufficient evidence that the home is unsafe, is what I said. So usually, make a statement, write it down, and then find and identify the right answer, okay? Otherwise you get lost in a sea of alternatives because they all look the same. There's never proof. We never say there's proof. We say evidence, sufficient or insufficient. We don't use the terminology proof, because that's like saying we know for sure. It's just all about evidence, and it's only one study. So we have a piece of evidence that it's the home, we have insufficient evidence that the home is unsafe. Okay, so we have no evidence, we have no reason to reject. That's the best answer from the list of options. All right. There's some more. I have one more problem. I still have questions from Catalin sent me some problems. Catalin sent me some problems to try. Otherwise, nobody sent me anything. So I'm going to tell you, I'm going to ask you for tomorrow, try the last one. Okay, so try this one. There's 2 problems here, so try, these are on the Moodle page. Try for tomorrow's class, and let me know if you want anything solved from the mock exam. You guys haven't emailed me about the mock. You should be able to complete the mock in under 3 hours, and you should do relatively well. Remember, the layout of the mock is identical to the layout of the exam you're going to get on Thursday. Alright, and for the exam on Thursday, I'll put the multiple choice questions in the system, and then I'll ask you to solve the problems and email them to me. And if you don't have any other questions, well, if you do have questions, email them to me, and we'll meet tomorrow about that. Okay, so keep working at this. I've done a lot of problems with the t-distribution. Go back and make sure, complete the review exercises, complete the exam. I'll put some more problems just for formulas 4 and 5, I guess. So I'll add those, additional problems for you to try. Alright, so I'll put a couple more problems up for tomorrow. Otherwise, good night, and keep studying.